Let's apply using these z-scores to some probability kinds of problems. We can ask the question, what's the probability that a woman is 34 years old or older when they have their first child? In other words, we're asking, what's the probability of being 34 or older? I like to go ahead and graph these problems out. There's my normal distribution. I know that the mean is about 23. We're asking, what's the probability being 34 or older? In other words, being in this tail of the distribution. This is a relatively simple problem. The first step is to solve for our z-score for somebody who's 34 years old. There's our z-score. So we know that this value of 23 converted to a z-score is 0, and the value of 34 converted to a z-score is 2.12. Our next step is to go ahead and use the z-table to look up this value of 2.12 to give us the area under the normal distribution between the ages of 23 and 34, and we'll subtract that from 0.5 to get the remaining area, or the shaded in area in the graph at the bottom. So here's a z-table that I happen to like, and we're going to look up our first area under a normal distribution based on the z-score we calculated. We have a z-score of 2.12. So I come to the column labeled z and I read down, just follow the cursor down till I get to the 2.1. It's right here. And then I'm going to read across till I get to the 2.02. And there's my 0.2. Reading directly off the table, you can see that the area under a normal distribution between a mean, when converted to a z-score, which is equal to 0, and a z-score of 2.12 is 0.4830 of that distribution. And then, of course, we can calculate the area beyond as 0.5 minus 0.483, which gives us 0.017. If I have a z-score of 2.12, my area between the z of 0 and 2.12 is 0.4830, and therefore my area beyond is 0.5 minus 0.4830, which is equal to 0.017. So we can see now that if we take a woman at random, if we were to sample people at random, the probability of getting a woman who had their first child at age 34 or older, the area in the right tail of that distribution, is approximately 0.017. Now I'm going to erase some of this and show you how you can check your answers. I know that if I label this area A, and this area B, and this area C, I know that A is equal to 0.5, that B, which I looked up in the table, is equal to 0.4830, and I know that C, which I got by subtraction, 0.5 minus 0.4830, is 0.0170, and that these have to sum to 1. I know I've done my problem correctly if they sum to 1, or at least I haven't made an error with my earlier subtraction. Now we're going to solve a similar problem. We're going to ask, what is the probability that age is less than 18 years old. So again, the problem here, if I graph this out, is to convert to a z-score, use the z-table to solve for all the various probabilities, and choose the correct one to answer this particular problem. I know that this is approximately 23 years old, and we're asking about people who are 18. Again, I'm going to label these areas so I can check my work later. And I know that this area is 0.5, and I need to find the area between 18 and 23. And when I find that area, I then subtract that from 0.5 to get the area less than 18. So like before, our first step is to go ahead and solve for the z-score of a person who's 18 years old. Notice that I have a negative number here. Again, the implication or our understanding is that 18 is less than the average of approximately 23. At this point, I need to go to the z-table and look up the appropriate area under a normal distribution between the ages of 18 and 23, and then subtract that from 0.5 to get the area 18 and under. The z-score for a woman aged 18 is minus 0.96. This table doesn't have any negative numbers, so I'm just going to look up the 0.96 and remember that it's to the left of our mean. I read down the column labeled Z until I get to 0.9, and I just read across until I get to the 0.06, and I read right off the table the area under a normal distribution between a mean of 0 and a z-score of minus 0.96 is 0.3315. And the area below that is 0.5 minus 0.3315, or 0.1685. Let's go ahead and write in the things that we know after looking at the z-table. I know that the area C is 0.5, or half the distribution, that the area labeled B from my z-table lookup is 0.3315, and that my area A is 0.1685. And again, to check my work, these numbers have to add to 1. So we know that the probability of being 18 years old or younger when a woman has their first child is approximately 17.17 or 17%. This example, we're going to ask the question, what's the probability that a woman has an age between 18 and 29 years old. Again, drawing this out, always helpful. Here's our distribution with approximately 23 as our average, and we're asking about people that are between the ages of 18 and 29, and that probability will be equal to this area of the graph. You can see here that this area captures or contains the average, so this is what I called an addition problem. We're going to have to calculate two z-scores, the z-score for 18 and look up its area, and the z-score for 29 and look up its area, and then we'll add those two areas together. Let's solve for the 18-year-old first. And then we'll solve for our 29-year-old. Now I need to turn to the z-table, which you can get online or find in a statistics text, and look up the associated areas under that distribution. I have two z-scores to look up in this problem, a z-score for a person 18 years old and a z-score for a person 29 years old. Respectively, the z-score for 18 is minus 0.96, and just reading directly from the table, I see that value is 0.3315, and the z-score for a 29-year-old woman is 1.16. So again, I'll read down here. Here's my 1.1. I just read straight across till I get to my 6. And I can see that that value is 0.3770. I'm going to label these areas. And then figure out everything I can to fill in the gaps here. My z-score for somebody who's 18 years old has an associated area of 0.3315, and my z-score for somebody who is 29 years old, when I look up the area in the z-table, is 0.3770. I need to figure out the areas for A, B, C, and D. And I do it in the following way. The area from 18 to 23, which is section B, is 0.3315. The area from 23 years old, or the mean, to 29 is 0.3770. If I subtract this number from 0.5, I get the area in A, which is 0.1685. And if I subtract C from 0.5, I get 0.1230. And again, this should sum to 1, which it does. And now I need to solve for B plus C, which will give me my probability that a woman is between the ages of 18 and 29 when they have their first child. And so the answer to this problem is approximately 0.7085, or we can just call it about 0.71. The probability of a woman having their first child between the ages of 18 and 29 is approximately 0.71. This example will be similar to the last one, but we're going to ask, but you'll see that the solution is a little bit different. We're asking for the probability that a woman is between the ages of 28 and 38 years old when they have their first child. Well, if I graph this out, I start from here with the mean. We're saying between the ages of 28 and 38. You can see that I need this area, and this is what I called in the lecture notes a subtraction problem. It's a subtraction problem because the area that I'm interested in does not capture or surround the average. It lies outside of it. In this case, it happens to lie on the positive side, but the logic is the same if it was on the negative side. Again, we're going to label all these areas and then describe how to solve the problem. What we're going to do is we're going to calculate two z-scores, one for a woman who's 28 years old, and get the area between 23 and 28 years old. Then we're going to calculate the z-score for a woman who's 38 years old and get the area between 23 and 38, and then we'll subtract the smaller from the larger to get the shaded in area. And of course we can figure out the area in the other parts of the distribution by doing some additional subtraction. So let's go ahead and solve for our two z-scores. And now we have to turn to our z-table and look up the area under the normal distribution between 23 and 28. That's associated with the z-score of 0.97. And between 23 and 38, which is associated with the z-score of 2.89. I have two z-scores, one for a woman 28 years old and one for a woman 38 years old. Respectively, the z-scores are 0.97 and 2.89. So I'll read down the z-score column to 0.9 and then read across to the 0.7 and read directly off the table. The area between 0 and 0.9 z-scores is 0.3340. My other z-score is 2.89. Again, I'll read down this column till I get to 2.8 and read all the way across the table to the last column. So that's my 2.89, and I see that my z-score is, the area under a normal distribution between a z-score of 0 and a z-score of 2.89 is 0.4981. There we go. There's our two areas taken from the z-table. If I simply subtract the smaller from the larger, I get 0.1641, and I can just go ahead and now figure out my areas. So our area for area A is 0.5. We know that between 23 and 28 is 0.3340. We know that beyond the age of 38 is going to be 0.5 minus 0.4981, or 0.0019. And we've already solved for that area C, which is the difference between 0.4981 and 0.3340, which is 0.1641. And again, those will sum to 1. So if we were to try to answer the problem, what is the probability that a woman is between the ages of 28 and 38 years old when she has her first child? The answer would be approximately 0.16. Or 16% of women tend to have their first child in that age range.